everyone, welcome to our math class. Today we will start to complete some parts of the curriculum of middle 3 that will help us to understand our curriculum in the senior 1. First, I have to start with the geometry part, which is talking about the central angle and the inscribed angle and the relation between them and the arc. To remember this, I have first of all a circle. Of course, M is the center of this circle. Okay? According to the M is the center of this circle, so I have here a central angle. Right? Here I have MC is the radius and MB is the radius. So here I have an angle included between two radii and its vertex is the center. Right? This angle called central angle. This angle called central angle. Okay? Okay, what about this angle? This angle, this vertex is lying on the circle. This point is lying on the circle. And AB is a chord and AC is a chord. So the angle which is included between two chords and the vertex of it lie on the frame of the circle called inscribed angle. Called inscribed angle. Inscribed angle. Okay? But this angle is called central angle. Central according to the center. Central angle. Okay. What is the relation between these two angles together? We will find that the measure of the central angle, equal to the measure of the subtended arc. What's the meaning of subtended arc? The arc which is opposite to it. The arc which is opposite to it. Any arc, BC arc, like BC arc, it has a measure and a length. It has a measure and a length. Okay? Measure of the arc, its unit is degree like the angle. So, for example, if I know that this arc is 60 degrees, so I get now the measure of this arc. The measure of this arc is equal to the measure of the central angle. The measure of this arc equal to the measure of the central angle. Okay? And the measure of the inscribed angle equal to half the measure of the subtended arc. Equal to the half of the measure of the subtended arc. Remember, focus. Here I have a chord and here I have another chord, and this is the subtended arc to it. So the central angle here is half to the measure of the arc subtended by it. So this angle equal to 30 degrees. Now simply you can get the relation between the inscribed angle and the central angle. Of course, now we know already noticed that the inscribed angle equal half the measure of the central angle. Right? So first of all, the first rule, the central angle takes the measure of the subtended arc, and the inscribed angle half the measure of the subtended arc, and the inscribed angle equal to half the measure of the inscribed angle, which is both of them subtended by the same arc. Okay? Second idea, I have what? I know that this measure of the circle, all of the circle has a measure. Okay? All of the circle, its measure is 360 degrees. The whole circle, its measure is 360 degrees. So, if this minor arc is 60 degrees, so it's simply to get the major one, the measure of the major arc. Now I can simply make 360 minus 60 equal to 300 degrees. Okay? Okay. Second idea. What is this rule? And I will use this for what? This rule solves the relation between the measure of the arc and the length of the same arc. The measure of the arc and the length of the same arc. Okay. For example, here I have the same exercise, and the measure of the arc BC equals 60 degrees, and I ask you to get its length if the radius is, for example, 7 centimeters. Okay. Now I will use this rule. Simply the measure of the arc over the measure of the circle. What is the measure of the circle, which is 360, equals to the length of the arc over the length of the circle. The circle has a length, of course, the length of this point according to another point, to repeat it again, it will be the circumference of the circle. Okay, now what is the circumference of the circle? I know the rule, which is 2 by r, right? So I can solve an equation. I have fraction equal fraction, so easily I can make scissors or cross multiplication. Here I have measure of angle, measure of arc BC equal 60 degree over 360 degree equals to length of arc BC. It's easy to get length of arc BC now because it's only the one unknown, over 2 times by, do you remember what is by? It's approximated value of 20 over 7 divided by 7, right? Now, I can simplify 7 by 7. So, I have 60 over 360 equal to length of arc BC over 2 times 22 equal 44. So, of course, you can get the result easily. I can get the length of BC by scissor. 44 times 60 over 360, and easily I can get the result. And now I can simplify, divided by 60 equal 1, divided by 60 equal 6, so the length of PC, it will be 44 over 6, it will be 7 and vertically centimeter according to the unit of the radius. Okay? Okay. The second idea, we will revise very important idea according to arcs and central angle and inscribed angle. He said to you now, if measure of arc AB, this one, equal to measure of arc CD, so of course length of arc AB equal to length of arc CD and vice versa. Vice versa, that means if the length here equal the length here, so the measure equal to the measure. And of course will be the central angle equal to the central angle. Okay? Another important idea. If I have two chords parallel to each other, if I have two chords parallel to each other like AB and DC, here I have AB parallel to DC. So the arc which is lie between them like AC and BD will be also equal in measure. So of course if I have chord AB parallel to BC, that means the measure of arc AC equal to the measure of arc BD, and so on. It will be the length of arc AC equal to the length of arc BD. And here he said to you a tangent. Remember the tangent? The tangent touch the circle at a point. So here I have a tangent and here I have a chord. They are parallel to each other. That means this arc is equal to this arc in measure. Okay, again, according to this, if I have CD parallel to AB, that means measure of arc EA equal to measure of arc EB. Okay. Now I get the some relation between the central and the inscribed angle. We know that A and B is a central angle because value N is the center. So it's equal to the measure of the subtended arc, which is measure of arc AB. So if the angle here is 70 degree, that means this measure also will be 70 degree. Okay? What about the second drawing? Here I have a central angle and here I have the inscribed angle. What do you know? This central angle equal to the subtended arc, the measure of the subtended arc, which is CD. And the inscribed angle equal to also half the measure of arc CD. So measure of angle B, which is central, is equal to double the inscribed angle, equal to double the inscribed angle, or the inscribed angle equal half the central angle. Okay, and here I have a new one called the angle of tangency. What is the angle of tangency? Here I have a tangent, and here I have a chord of tangency. So the angle between them called the angle of tangency. Again, here I have a tangent, here I have a tangent, and a chord of tangency. So the angle between them, this angle between them, equal to the angle of tangency. This angle of tangency is subtended by the arc which is AB, right? So its measure equal to half the arc of AB, like the inscribed angle. That means this angle equal to half the measure of the central angle which is subtended by the same arc. So the measure of the central angle equal double the angle of tangency. So the angle of tangency is half the arc. The inscribed angle also is half the arc, but the central angle is equal to the arc. So central angle is double the inscribed and the angle of tangency. Okay. Now again, measure of angle of the inscribed angle equal half the arc. And if I have two inscribed angle subtended by the same arc, so by logic it will be equal in measure. And here I have the relation between inscribed angle and a central angle. It's clear that inscribed equal half the central, or the central equal double the inscribed. And here I need the relation between the inscribed and angle of tangency. Again, this is the tangent, this is the chord of tangency. So here is this is the angle of tangency, and this is the arc which is subtended by, and here I have an inscribed angle. That means this angle equal to this angle. So measure of angle C, which is inscribed, equal to measure of angle ABD, which is angle of tangency. Okay. Here, by logic, if the measure of the arc equal to the measure of the arc, so the two inscribed angle it will be equal to each other. Okay? And this idea is very important. If I draw a semicircle, if I draw an inscribed angle on a diameter, it's opposite to a diameter, so I can draw an inscribed angle in a semicircle. That means this angle is right, and this angle is right. Okay? Okay, now let's solve simple questions now. Here I have a central angle which is 110 degrees, and here I have inscribed angle subtended by the same arc. Now what is the relation between the inscribed and central angle? Inscribed equal half the measure of the central angle. So now measure of angle C equal 110 divided by 2 equals to 55 degrees, or half times 110 I will get 55 degrees. Yes, here I have an inscribed angle equal to 35, and we need to get the central angle. Yes, the central angle is double the inscribed angle. So now measure of angle M, which is BMA, equal to double 35 equal 70 degrees. Right? What about this? I have equilateral triangle MAB, and I know that each angle in the equilateral triangle equals 60 degrees. So measure of angle M equals 60 degrees. What is the type of angle M? Angle M is an central angle. So I need an inscribed angle subtended by the same arc. I know that the inscribed angle equal half to the measure of the central angle subtended by the same arc. So measure of angle C equal half times 60 equal 30 degrees. What about this? Here I have inscribed angle 45, and here I have central angle. Okay, central angle it's double the inscribed. That means this is 90 degrees. And he asked you to get the angle MAB. I know that measure of angle AM equal 90 degrees is right angle. How can I get the measure of angle MAB? Okay, note that MA and MB are two radiani in the same circle. That means they are equal in length. So I have now an isosceles triangle MAB. How can I get the measure of the two faces of the isosceles triangle? I can make 180 minus 90, the vertex angle, and the result divided by 2. So measure of angle A equal 180 minus 90 equal 90 divided by 2 equal 45 degrees. So this angle equal 45 degrees, and also this angle is 45 degrees. Okay, let's do some exercise. Here I have AB chord parallel to DC chord, and we say to you B and C equal 60 degrees, and he asks you to get the measure of the arc AD. Okay, first of all, I have a central angle which is 60 degrees. That means the subtended arc also is 60 degrees. What do you think about the two chords are parallel? That means the two measures are equal in measure. The two arcs are equal in That's mean measure of arc AD also is 60 degree. What about this? I have here AB parallel to DC, that means this arc equal to this arc. And he said to you arc DEC equal 80 degree. DEC, that means this part equal 80 degree. And he asked you to get measure of arc AC. Okay. Let's remember the important thing. Here AB is length passing this whole angle. That means it's a diameter. That means BA, this part, is a semicircle. The semicircle is measured equal to half the measure of the circle. The measure of the circle equal to 160. That means the measure of the semicircle equal 180. This part only equal 80 degree. Can I cancel 80 from 180? Yes, of course, it's not subtraction. So 180 minus 80, I will get 100 degree. This 100 degree distributed among two equal arcs. Two equal arcs, okay? So to get the measure of one arc now, I can make 100 divided by 2 to get 50 degree. Okay? Now I have AB intersect CD equal point E and measure of angle D equal 30 degree, DAB equal 110 degree, and he asked you to get the measure of arc AD. Okay, it's simple. I have a triangle inside and I know the measure of the sum of the measure of the interior angle of any triangle equal 180. So how can I get measure of angle B? 180 minus the sum of 110 plus 30. So equal 180 minus 140 equal 40 degree. So this angle is 40 degree. But think a very important thing. This angle is inscribed. And the inscribed angle half the measure of the arc, subtended arc. That means the measure of the subtended arc equal double the inscribed angle. So I will double the 40 degree. So 2 times 40 degree equal 80 degree. Okay? Here I have AM bisect measure of angle BAC, and I know that measure of angle ACM equal 25 degree, and he asked you to get the arc of AC. Okay, first of all, I have MA and MC are two radii in the same circle. That means this triangle is isosceles, AMC is isosceles. According to the isosceles triangle, I know measure of angle MCA equal to measure of angle MAC. So it's clearly to know that measure of angle MAC equal 25 degree. The half of this angle all is 25 degree. And I know that AM ray is a bisector. That means this part MAC equal 25 and MAB equal 25. That means measure of angle A whole ABAC equals to 50 degree. But BAC is the inscribed angle, which is half the measure of the subtended arc. So to get this measure of the subtended arc, I have to double the 50, so I will get 100 degree. Okay? Another idea. Here, the first one. AB is a diameter. What do you know about the diameter? That's mean it's BCA is an inscribed angle subtended by a diameter. That means it's a right angle triangle. So measure of angle ACB equal 90 degree. And he said to you that measure of angle A equal 30 degree. And he gave to you the radius is 4, so BM is 4 and MA is 4. So the diameter is 8 centimeter, and in the same time it's the hypotenuse of the triangle ABC. And we asked you to get the side BC. Remember, we took it from middle to in the right angle triangle. If I have measure of angle 30, the side which is opposite the measure of angle 30 is half the hypotenuse. And the hypotenuse here is 8 centimeter. That means BC equal 4 centimeter. Okay? Okay, another one. AB is a diameter. Okay? It's simple. AB is a diameter. That means measure of angle C is right angle triangle. So X and 2X are two complementary angles because their sum also will be 90 degree. So simply I can add 2x plus x and I equal it by 90 degree. So 2x plus x equal 3x equal 90 degree. So x equal to 30 degree. And he asked you to get x. Of course it will be 30 degree. What about this, the other one? I have a circle of center N, DAB equal 140 degree, measure of arc AB equal 120, and he asked you to make measure of angle B. Don't confuse, CA here is not a diameter because it's not passing through the center. Okay, it's an inscribed angle, but it's not lie on a diameter. So this angle, it's not measure of angle B, it's not right angle. Okay, how can I get measure of angle B? Simple. I have an arc measure of arc AB equals 120 degree. That means I inscribe the angle which is subtended by the same arc, which is BCA, equal half the measure of the arc, which is 60. Now I want to get this one. Remember the exterior angle we took in middle one? That I have measure of angle B plus measure of angle C equal 140. Angle B plus 60 equal 140. Now it's easy to get measure of angle B, which is 140 minus 60 equal 80 degree. Of course, if you forget this theorem, I can get the supplementary here by 40, and I get this angle by the interior angle of any triangle. Okay? The last one. I have here measure of N is a center, and they say to you measure of angle N minus measure of angle A equal 50 degree. Okay. What do you think? What is the relation between this angle and this angle? This angle C and B is a central angle subtended by the arc BC, and the measure of angle CAB is an inscribed angle subtended by the same arc. That's mean measure of angle M double measure of angle A. So I can rename M by 2x, and I can rename x A by x, right? Because the central angle doubles the inscribed angle. And now I can solve the equation using one variable or one unknown. I know that 2x minus x equal 50. So simply 2x minus x equal x equals to 50 degree. So I already get measure of angle A, which is x equal 50 degree. I hope you understand this part. See you soon, inshallah.